Hello, dear young minds. Let us start a new chapter, and that chapter is work, energy, and power. All right. So, this chapter will be handled in three parts. The first and foremost thing is a definition of all these words. What is work? What is energy? What is power? All right. Then we go for the formulae. What are the different formulae based upon the definition? Then after that we'll go for the numericals. All right. So with this approach of definition, formula, and numericals, definitely our concept of this work, energy, and power will be very clear. Concept clearance. All right. So all the concepts will be cleared. Now let us take a situation. Now for example, your exams have arrived and you say them you are working very hard. Working very hard. Your parents have come to you and they are asking you to eat food or drink milk, and you are saying I'm working very hard. Is this the work what we are going to study in physics? Definitely not. You are thinking, right? You are thinking, is it work? Thinking, is it work? Is it a mental work? For sure, yes, it's a mental work. But in physics, we don't study about that kind of work. The work has a different kind of definition and it has a different formula, and the numericals, whatever comes on work, will be following all those numericals to strengthen your topic. All right. Then what is this work? If you are reading and you are working very hard, you are thinking, you are doing that mental work. If this is not work, then what is work? From the physics perspective, let us start to study. Let us see this word work. Okay. So what is this work exactly? For example, there is a body here. Okay. There is a body of some mass. On this body, you have applied some force, for example. Now, if this body do not move, if this body do not move means what is the work done? You tell me. If this is not moving means the work done is zero. You are not doing any work. For the work to be done, you have to apply some force and this body has to move, right? For example, this body has come here. Okay, the same body has reached here and it has covered some displacement. Yes. Okay, this is the displacement of the body. Then we can say that work is done. For the work to be done, there has to be there have to be two things. So one is force, for sure, how much force you are applying, and there should be some displacement, then only work is possible. All right. The simple definition of work is product of force and displacement. Very simple definition for your 9th standard. Product of force and displacement. Very, very simple definition. Okay, you can take this work is equal to force into displacement. Very simple definition. All right. Now if you go for the unit of work, if you are going for the unit of work, what is the unit of work? Force means Newton and displacement is meter, Newton meter, and this itself is known as joule. And you can represent it with J. Somebody call it joule also. Joule or joule, anything is fine. So that is the unit of work. Is it clear? So what is this? What I have told you? For the work to be done, there have to be force and displacement. And if any body is there, you applied some force, and that due to that force the body got displaced, then definitely some work is done. What is the definition of that work? What is the formula of that work? Force into displacement, and unit is Newton meter, and that Newton meter itself is known as joule. All right, fine. Let us do some numericals so that the concept become quite clear. 100 joule of work is done to displace a body for 25 meter. What is the given data? How much work is done? 100 joule of work is done to displace a body for 25 meter. That means displacement of the body is 25 meter. Now they are asking what is the force applied on the body. So force is equal to question mark. This is quite a simple question, right? So work is equal to, what is the formula? Force into displacement. What is the work? 100. How much force is applied? We don't know. What is the displacement? 25. So 25 ones are 25 fours are. So 4 is equal to F means force is equal to 4 Newton. So 4 Newton of work is 4 Newton of force is applied. Let us try to understand this. For example, there is a body, and on this body we have applied a force of 4 Newton, what we have got here. And if this body has moved for 100 meter, for example, this body has come here for how many meters? For not 100 meter, how many meters they have mentioned? 25 meter, no? So for example, this body has come for 25 meter. That means if you multiply this 4 and 25, then you are going to get the work of 100 joule. Alright, that is the meaning of it. Moving forward to next question, let us have a look at this question. This question is very important. A body's velocity changes from 10 meter per second to 20 meter per second when a force of 200 Newton is applied on a body of mass 20 kg. So much of data is given. What is that? First thing is u is equal to 10 meter per second. This is the initial velocity. And it changes to 20 meter per second, means final velocity is 20 meter per second. And the force applied is 200 Newton. The force is 200 Newton. Alright. And the mass of the body is 20 kg. Mass of the body is 20 kg. Alright, now what they are asking, find work done on the body during this time period. Look at this, if the velocity has changed from 10 to 20 means definitely some work would have been done, because velocity has increased. Work is equal to question mark. Now they are asking work means, for work we need force and displacement, right? Force into displacement we want. Now force we have, how about displacement? Let us try to find out the displacement by the given data. Look at this, force is given, mass is given, displacement comes from what? You can use formula 2as is equal to v square minus u square also. Time period is not there, no? So that's why you should be using this formula. Now 2 into acceleration means what? You don't have the value of acceleration right now, but that acceleration can be calculated by using this formula. Look at this, f and m is there. By using this f is equal to ma, just check whether you are able to find out the value of a. F means how much is that? 200 Newton. And m means what? 20 kg. And a we don't know. A is equal to how much that becomes? That becomes 200 divided by 20. So 0 0 get cancelled, 2 ones are 2 tens are. So the value of acceleration is 10 meter per second square. So this is the value of acceleration. Now we can take this acceleration and put here and find out the value of displacement. Let us see that. So what is the formula? The formula is 2as is equal to v square minus u square. 2 into a. How much is the value of a? A is 10, just now we got 10 into s is equal to v square is 20 square minus u square is 10 square. So it becomes 20s is equal to 400 minus 100. So then it becomes 20s is equal to 300. Alright. So then we have s is equal to 300 divided by 200. 20, then 0 0 get cancelled, 2 ones are 2 15s are. So the value of displacement is going to be 15 meter. Alright, so it's quite a simple case. Now they're asking about work means, you can easily find out the value of work, right? So work is equal to force into displacement. Now how much was the force? The force was 200 Newton. Alright, 200 into displacement is 15 meter. So it becomes 15 twos are 30, then other 2 zeros. So work will be 3000 joule. So 3000 joule of work has to be done. Alright, moving forward, I hope the concept of work is quite clear to you. What is the formula for work already have discussed. Alright, so the meaning of work, in physics, for the work we must have force and displacement. I have told you that. Okay, the basic definition for 9th standard. Then I have took you through these numericals. Now it's time for us to look at one more concept, that is positive work and negative work. Very, very important, right? Let us take this. For example, here is a body. Okay, here is a body. On this, you apply some force, for example. Let us take this force is like F1. So this is like 100 Newton. You have applied a force of 100 Newton. And somebody else is also applying some force here, F2. Let us take this to be, 40 Newton. Let us take this. Now, where the body will move? Definitely the body will be moving from left to right because this force is more, right? So that's why the body will be moving like this. Let us think that this body has displaced for some distance. I mean, let us take the displacement to be, let us take it as 10 meter. For example, the body has moved for 10 meter. Now, there are two forces, no? So, work done by F1. One is work done by F1, work done by F1, and another thing is work done by F2, work done by F2. Okay, there are two things. What is the work done by F1? Let us call that as W1. Alright, so that is quite simple. Force 1 into displacement. How much force that is F1 is there into displacement? What is the value of F1? That is 100 into what is the value of displacement? That is 10. So it is going to be 1000 joule. So the work done by this 100 Newton force is 1000 joule. This is quite clear. Now look at this work done by F2. If you take work done by F2, W2 is equal to, if you take F2 into S, and if you just write it as 40 into, then displacement is 10. So if you say 400 joule, it becomes wrong. Very, very important. Try to understand this. Okay. Whenever, have a look here, where the body is displacing, the body is getting displaced in this direction. No? Look at this from left to right. But where you are applying the force, you are applying the force in the opposite direction. Whenever the direction of the applied force and direction of the displacement both are opposite, at that time you have to put one minus here. You have to put minus. Very, very important. Very, very important point. I will give note of this, but try to understand this. See, on this body, how you are applying the force? You are applying the force like this. F2 is being applied like this. Look at this. You are applying the force like this. In this direction, you are applying the force. But where the body is moving? The body is moving in the opposite direction. That's why you have to give one minus a sign. So then it becomes minus. F2 means how much is that? 40 into S is 10. So it becomes minus 400 joule. Alright, so this is the work done by the second force, that is F2, and this is the work done by first force. I hope this is getting clear. Let us take some practical examples. For example, there is a body again. Okay, there is a body here, and you are applying some force here. Okay, this is called as force, for example, and this body will move and this will come here. Okay, this body will reach here for it some displacement. Yes, it can be any value. Now this is the floor, for example. Okay, this is the floor here. This is the floor what we have. Don't you think this floor will be applying some friction on this body? Look at this. This floor will be applying some frictional force, no? Some friction. Let us call that friction as a small f. Some frictional force F. Now, when this body is moving, the work is done by two forces, no? One is a work done by F, work done by capital F. Capital F means what? This capital F is externally applied force, or external applied force it is. External applied force, it is capital F. How about this small f? This is friction. Work done by external force if you are taking, so how much it becomes? Work is equal to force into displacement. Directly you can write and everything will be fine. Why you are writing directly F into S? Because the force is also in this direction. Look at this, the force is in this direction and displacement is also in this direction. Both are in the same direction and you can write directly. Now if you come to friction, work done by friction, work done by frictional force, or you can just call it as friction also. Work done by friction, if you say this, what will be the formula? Please tell me. Look at this, where is the frictional force? The frictional force is acting like this, but displacement in the opposite direction. So that's why what will be the formula? The formula will be minus F into S. Definitely the work is going to be negative. So work done by frictional force is always work done by friction, or frictional force you can say. Work done by friction is always negative. Why it is always negative? Because it is always opposite to the motion. The body is moving here means the friction will be applied in the opposite direction. So that's why work is negative. One simple thing we got. So what is that? If force and displacement are in same direction, in the same direction, in the same direction means we are going to get what kind of work? We are going to get a positive work. Alright, if F and S if F and S are in opposite direction, then whatever work we are going to get, so that work will be negative. As we proceed into the video, you will understand it through the numericals. Right now, make a note of all these things. Moving forward, let us take one example here. Alright, otherwise before that you see this, there is a body, okay? There is a body here. Now gravitational force is pulling it, mg. Now I mean this is the floor, okay? This is the floor, and the force is downward, no? So this mg is nothing but force only. But if you are lifting it above, for example, the body has reached here, okay? The body has come here. Alright, now the displacement is in this direction and force is downward. Look at this, the force is downward and displacement is above, means definitely the work done by gravitational force will be, it will be negative or not. Why it is negative? Because both the gravitational force and displacement are in opposite direction. Alright, this is the concept. Let us take this numerical. A body of mass 50 kg is lifted to a height of 10 meter. Find the work done by gravitational force. Alright, for example, here is the body of how much mass? 50 kg. This is the 50 kg mass. 50 kg mass means it will be experiencing one downward force, that is weight. Alright, that is only known as weight, right? That weight itself is the force. Weight is equal to force is equal to mg, or you can write it as 50 into g is 10. So the the weight experience, this is weight, okay? Please don't confuse it for work, otherwise you can write it as force only directly. So how much is that? 500 Newton, and you have displaced it above for a displacement of 10 meter. Alright, now let us find out the force. Force is equal to, what is the formula now? The force is in the downward direction, but displacement is in the upward direction. Both are opposite, that's why it becomes a minus Fs, or minus F into S. Minus F means this is 500 into S is 10. So it becomes minus 5000 joule. Why the work value is negative here? The work value is negative because the force and displacement are in opposite direction. Work done by which force is also very important. Now look at this. If you take this example, here we are applying the external force, no? This external force, whatever it is doing the work, that is positive, and whatever this frictional force is doing, that is negative. Work done by which force is also very important. Now here work done by this gravitational force has come to be negative. Let us take one more example. A 100 Newton of force is applied on a body to displace it for 15 meter. Alright, 100 Newton force is applied to displace it for 15 meter. If the body has experienced a friction of 5 Newton in the entire journey, find the work done by external force and frictional force. Okay, work done by external force. Work done by external force. Okay, let us take this work done by external force. Okay, so what is the work done by external force? So work is equal to force into displacement. Directly we can write. Why? Because where we are applying the force, there only the body is moving. So what is the value of this force? 100 Newton. For how many meters it has moved? For 15 meters. Look here. So it becomes what? 1500 joule. The work done by this external force is 1500 joule. Alright, then we have friction also. It is experiencing a friction of 5 Newton. Just observe this situation. No? Here is the body. Alright, and you are applying a force here. How much force you are applying? You are applying a force of 100 Newton. It is given. Alright, and here is the floor, and this body is going to experience a friction, right? So it is experiencing a friction here in the opposite direction. What is the value of this friction? The value of friction is 5 Newton. They have given directly, and this body is moving for 15 meter. That displacement is also given. That already we calculated. What is the work done by this external force? Now what is the work done by frictional force? WF means work done by the frictional force. Definitely the formula is minus Fs, right? Why it is minus Fs? Because the frictional force is from right to left, but displacement, the body is getting displaced in the opposite direction. That's why. So minus 5 into, what is the displacement? Displacement value is 15 meter. Alright, so it becomes a minus 75 joule. Alright, so this is a work done by frictional force. Once again I am repeating, work done by which force is very important. Moving forward, now let us come to the main topic, that is angle between force and displacement. Just now we have discussed, no? For example, here is the body, and you are applying the force like this, and the body is displacing in this direction. The body has reached here. The body also displaced in the same direction. Now both the force and displacement are in the same direction, means what is the angle between this force and displacement? Angle between force and displacement, what is this? 0. So if this is 0 means, so what is the value of work? The value of work is going to be positive. Alright, now here is the body. The body is experiencing force in the opposite direction. Okay, just now I have given example, no? It is not necessary that, if you are applying the force means the body will move like this. Is it possible like that? No. If you are applying the force like this, the body will move in this direction only. Okay, that is for sure. But I have shown you some situations, no? What are those situations? You have observed about friction and all, right? So here is the body, and whenever you are applying some force, the body is moving here. The body has reached here for some displacement that is there. Okay, but this body is also experiencing some frictional force here, no? Look at this. Now when you observe this, so what is the angle between this force means this frequency, this frictional force and displacement? What is the angle between them? 180 degree, right? The displacement is here, it is in this direction, and frictional force is in the opposite direction. What is the angle between them? Look at this. This is 180 degree. So whenever it is 180 degree, the work is going to be negative. So both cases, one is 0, another is 180 degree. Then we get the value of work as negative. You have to remember this. Now one more case I want to take here. Here is the floor. Okay. Here is the floor, for example, and I have kept one body here. Here is a body. Now on this body, we are applying some force. Okay. Some external force. Now this body will move here. Okay. This body has come here, for example. This body has come here and it has moved for displacement. Yes. Alright. Now look at this. How many forces are acting here? One is F external, that is there. And another one is friction, that is small f. And how about weight? For example, this body is having mass m, right? So it will be experiencing one downward force also, mg. Now is there any work done by this gravitational force? This mg is nothing but gravitational force, weight of the body. What is this mg? So this mg is weight. Alright. So now if you take three cases, first case is work done by F external. Work done by F external. If you take that as W1, so the formula is quite simple. So what is that? F external into displacement. It's over. This is the first case, because the force is also in this direction and displacement is also in this direction. Both are in the same direction. That's why positive. Now if you take work done by frictional force, okay, whatever this small f, this frictional force is there, if you take that to be W2, what will be the formula for this? Definitely it is minus, no? Why? Because the force is in this direction, that is frictional force, and displacement is in this direction. Both are in opposite direction. That's why we are going to get it as minus f into s. Minus f into s, that is work done by frictional force. Now how about this work done by gravitational force? Work done by gravitational force. Look at this. If you keenly observe, the weight is acting like this. But the body is moving in this direction. What is the angle between them? Here is the displacement and here is the force. The angle between them is 90 degree, right? So whenever angle between force and displacement is 90 degree, you can directly say the work done by this force is 0. Very, very important. I hope you are trying to understand. Let us take in the next page so that it becomes quite clear. For example, this is the floor. Alright. This is the floor and here is the body of mass m, for example. Alright. Now this body has to be moved here. From here to this place it has to be moved. It hasn't moved. Okay. Has to be moved. It has to be moved. If it has to be moved, where you have to apply the force? You have to apply the force in this direction, right? Where you want to displace the body, on this direction only, in this direction only, you have to apply the force. Then work becomes what? Positive. That's what we are discussing. Now instead of that, if you apply the force like this, look at this. If you apply the force like this, if you push it here, I mean from top to bottom, now what will be the work done? Look at this. The force is like this, the force is acting like this, but displacement has to be done in this direction. What is the angle between them? 90 degree. Now what is the value of work? 0, right? Because we are expecting that the body has to be moved from this position A to position B, but you are applying force, but you are applying force like this. I mean you are applying the force here, and displacement has to be in this direction, and it is 90 degree. Now definitely the work done is 0. So that's why this angle is, I mean 0 degree means work will be positive. If this angle between force and displacement is 180 degree means work is negative, and whatever this angle is there, if this angle is 90 degree means work will be 0. All right, fine. I hope you are getting what I'm trying to say. There are some questions like, I mean, a coolie, very important question. A coolie is carrying a load. A coolie is carrying a load. What is the work done? What is the work done? Okay, what is the work done? Usually people say work done is equal to 0. Okay, this is wrong. Okay, immediately we should not say like that. If work done by coolie is 0 means why we should pay the money? Look at the situation. Okay, for example, here is the coolie. Okay, here is the coolie. Okay, he is the coolie and he is carrying a bag here. Okay, this is the luggage what he is carrying. So let us take this luggage. Now he is moving forward carrying this luggage, and let us assume that he has reached here, okay, to this position carrying the load. So whatever load is there, by carrying that he reached here. Okay, and now that luggage has become yellow, right? Okay, let us paint it red. He has reached here. Now definitely he must have covered some distance. No, this is a displacement what he covered. Now whenever he is moving, no, so this whatever this load is there, it is applying some downward force, that is weight, correct? No, so that is the weight, that is mg, that is the weight. Now if you observe that, so that is like mg, so that is acting downward. And how about displacement? Displacement is in this direction. What is the angle? 90 degree. The work done by gravitational force, is equal to 0, that is for sure. Work done by gravitational force. Don't say that work done by the coolie is 0. No, work done by this gravitational force, whatever I have shown here, that is 0. But how about friction? When this coolie is moving in this direction, the friction is acted upon his legs, right? On his feet, the friction is there on his feet. This is friction. Now if you take work done by the friction means you have to take it as minus Fs, right? Why minus Fs? Because friction is in this direction and displacement is in the opposite direction. Look at this. So this angle is how much? 180 degree. That's why work has to be negative. The work done by this frictional force is negative and he overcomes it. He overcomes the frictional force and he moves forward. No, that's why we have to pay him. Okay, if he comes there and if he asks for money, you should not say work done by this coolie is 0. No, work done by the gravitational force is 0, but work done by frictional force is negative and he overcomes that. That's why we have to pay him. So that's why main concept is work done by which force. Work done by which force is very, very important. Okay, so right now for 9th standard you understand the meaning of work as force into displacement. Okay, what is work? Force into displacement. And whenever 0 degree angle is there, it is positive, 180 is negative, and 90 means 0 degree. If you understand this much and if you are able to do these problems, okay, then the task of 9th standard is over. When you go to 11th standard, there will be some other things. All right, please watch these videos in the playlist only so that you understand them in a better way. I have covered the chapters of motion, force and laws of motion, and gravitation also. Watch them, then come to this video so that you understand it in a better way. Thank you very much. Have a good day and bye bye.